Welcome to my YouTube channel, Business Corner. I am Mukul, Sarma, subject teacher. Today I shall discuss about argument of complex number. This is at case 1 first. That is, if z lies in the first quadrant of the argument plane, that is z is a complex number, and it is lies in the first quadrant of the argument plane, then this is the case. Let z is equal to a plus ib be complex number. Since z lies in the first quadrant, so a must be greater than 0, b greater than 0. We can now plot this point. If we take a point here, as conjugate pair is AB, and we can plot it in the argument plane as in figure. Conjugate pair is AB, therefore there is A, this is A, and this is B. And PM is perpendicular to X here, therefore this is A and this is B. And now if we join OP, then OP is the modulus of the complex number, and it is it was discussed last class. OP is the modulus of the complex number, and POM, the angle between OX and OP in the anti-clockwise direction, is called modulus of the complex number, and it is denoted by theta here, and in general it is denoted by ARGZ or AMPZ. ARGZ, argument of Z, AMPZ, amplitude of Z. It is. Now we find out what is theta, that is what is argument of Z or what is amplitude of Z. We see that triangle OPM is right triangle. From here, tan theta is equal to, that is perpendicular by base. Here is PM perpendicular, OM is base. Therefore, length of PM, this is B, or length of OM, this is A. Therefore, it is B by A. Theta is equal to tan inverse B by A. Tan theta is equal to B by A implies theta is equal to tan inverse B by A. Here B is imaginary part of the complex number, and A is the real part of the complex number. Thus, in the first quadrant, Z is equal to A plus IB implies ARGZ, argument of Z is equal to theta, that is tan inverse B by A. Now, what is in the case? Now, in the case 2, that is if the Z lies in the second quadrant. If Z lies in the second quadrant, let Z is equal to A plus B IB be a complex number. Since Z lies in the second quadrant, so A less than B. Here, A less than B and B greater than 0. We can plot in the argument plane in the figure. This will be the point here. This is A and this is B. This is A, this is B in the second quadrant, since A is negative here in the argument. And here OP is the modulus of the complex number, and OP POX, that is this angle. This angle is the argument, and it is theta. This angle is argument, and this angle in the clockwise direction, it is anti-clockwise. This is clockwise. This angle cos in clockwise direction, we consider it as alpha. Now, what is alpha? Tan alpha is equal to perpendicular by base. Therefore, PM by 1. Since alpha is an equiangle, therefore we write PM OM within the modulus. B by A, that is alpha is equal to tan inverse B by A. Now, what is theta? This is the actual argument of the complex number. What is theta? Theta is the argument of Z. It is pi. This is pi. It is anti-clockwise direction. Therefore, it is pi, and this will be subtract, and this is in the clockwise direction. Therefore, pi minus alpha, and alpha we have got, it is tan inverse B by A. Thus, if z lies in the second quadrant, then argument of z is equal to pi minus tan inverse b by a. If z lies in the third quadrant, case 3, it is if z lies in the third quadrant, that is, let z a plus ib is a complex number, and since z lies in the third quadrant, so we are a less than 0 and b less than 0. We can plot it in the argon plane as in figure. That is first, second, this is third quadrant. Here a less than 0 and b less than 0. Therefore, this point is there. And if we draw perpendicular, PM is the right perpendicular, OM is the base here in the triangle, right triangle coping, and we take this as alpha. Therefore, tan alpha is tan inverse b by a. It is same as above. Now, argument of z. What is the argument of z? Argument of z, there's theta. This is also the argument of z, and this is also the argument of z. OP, POX, this angle is the argument, and POX, this angle also the argument. Therefore, if this angle, we consider this angle as the argument, there is minus pi plus alpha. There is minus pi plus alpha. This is anti-clockwise direction alpha, this is plus alpha. This is clockwise direction minus pi. Or if the argument of z is theta, if we consider this angle, and from this to this there is pi. From this is alpha, therefore the pi plus tan inverse b by a. Now, case 4, if z lies in the fourth quadrant, that is, if z lies in the fourth quadrant, z is equal to a plus ib, complex number. Since z lies in the fourth quadrant, so a greater than 0, but b less than 0, and we can plot in the argon as in figure. There is the figure here. We have got this big. It is the point OPM. We are also right triangle. This is A, this is B. We can consider this is alpha. Now tan alpha is equal to, as in the above, tan alpha is equal to PM by OM, B by A. What is the argument of z? Now the argument of z is this angle, theta, this angle or this angle. If we consider this angle, this is complete angle minus alpha, minus this is alpha. Complete angle twice pi minus alpha. Or if we consider this angle, alpha is equal to, it is considered this angle, theta is equal to minus alpha, that is ARG is equal to minus alpha, since alpha is in the clockwise direction. So this is the case of fourth quadrant. Now case 5, this is if z lies on the positive x-axis. If z lies on the positive x-axis, therefore if this is point, therefore OP, angle between OP and OX is 0. Here, angle between OP and OX is 0. Therefore, ARGZ theta is equal to 0 here. If the point lies on positive x-axis, this if imaginary part is 0 of the complex number. Case 6, that is, if z lies in the negative x-axis, is the direction negative x-axis, then ARGZ negative x-axis, then angle between OP and OX, that is pi. It is in the anti-clockwise direction, therefore it is plus pi. If z lies in the positive direction of y-axis, that is positive direction of imaginary axis, that is if z lies in that point, then angle between OX and OP is 90 degree. It is anti-clockwise direction, therefore ARGZ is equal to pi by 2. And if z lies in the negative x-axis, that is negative x-axis, this is here is the position of the point, therefore, and we can take the argument of z as if we take this angle, this is theta and this is minus 90, because it is clockwise direction. And if we consider this angle, that is 3 pi by 2, this is, therefore ARGZ in this case is minus pi by 2 or 3 pi by 2, because pi by 2, that is 3 pi by 2, or it is in the anti-clockwise direction, so pi is positive. Now this is all about the argument of complex number. Next class I shall discuss about solution of some problem which are related to argument and modulus of complex number.